Well, thanks everybody for either joining in live or watching this in the recording. My name's Tom Stace. I'm a professor in the physics department at the University of Queensland, which is in Brisbane in Australia. And so we're offering a master's program in quantum technologies. It started mid last year. So June, the semesters in Australia run from about February to June, and then July through to about November. And so we started the program in 2019. We've had the first cohort run through, and they're just about to complete. And the second cohort started this year. The program we've got is an 18-month program, but before I get into the details of the program, I'll share my screen and can you see my screen there?
Yes, looks good.
So what I'm sharing with you is perhaps a slightly unexpected thing. It's just a web page from Physical Review A, and it's showing a paper called the Quantum Optical Friedman Gate, and it was written by a person called Gerard Milburn in 1989. And you might wonder, well, why is he showing that? Let me go to that paper. So here's the headline of the paper. Gerard Milburn at the time was a young guy. He's now semi-retired, based at the University of Queensland in Brisbane, where I am. And he wrote this paper in 1988, so over 30 years ago. And it's the first proposal for a physically realizable quantum gate. And so the pedigree for doing quantum science at University of Queensland is old. If you think about the dawn of quantum computing, it's not many more years before that, and it certainly predates many of the algorithms that were developed subsequently. And so University of Queensland has been really at the forefront of developing quantum science for many years, and it's also now the home to a much bigger effort in quantum computing and quantum research. So we have what are called centres of excellence, which are federal government sponsored research centres, each with dozens of researchers across the country. And we have two of those that are specifically focused on quantum computing, one of which is even centred at the University of Queensland. That's the centre I'm in, which is called the Centre for Engineered Quantum Systems, or EQUS for short. You can go to our webpage if you like, equus.org, and you can check out some of the stuff that we do within that Centre of Excellence. You can see there's a series of short films that on quantum themed subjects that are being run. In fact, if you're interested in participating in that as a competition, please join. And you can see that we do a lot of stuff on quantum outreach, as well as a lot of basic quantum science research. So UQ really has had a long history of working on quantum science, and we're very proud of that. And so one of the things we decided three or 4 years ago was to start packaging that up, those skills and the educational experience we've got in teaching quantum science, and offer a master's program, which we called then the Master of Quantum Technology, which is common to a lot of places. And so here's the front page for that program at the university that I'm at, the University of Queensland. And so if you type into your web browser search engine, Master of Quantum Technology at UQ, you'll come up with this, and it gives you a variety of resources to help you understand what's available. You can click through and check things out. There's scholarships available and so on. And there's a little video. I don't know if I can play that video conveniently over this presentation, but I'll just put the link through in the chat browser after.
Oh, do you want to show it, Tom? You can.
I can. I'm not sure if it'll play.
Yeah, you'll need to when you share your screen. When you identify what you want to share, on the bottom left corner, there's a checkbox for audio to come across. Okay, so if you just bounce your share again.
Okay. I'll share computer sound. There we go. So if I play that, I wonder if it'll work.
Program is a very unique program. So UQ's Master of Quantum Technology program is a very unique program. It's the first of its kind in Australia. The idea is to train people who previously have trained, say, in computer science, chemistry, mathematics, engineering, to equip these people with skills that will be useful for quantum technology industries. You have all these physics and all these technologies all housed in one place. So if you want to gain knowledge on all these systems, you can get it from here.
Great. So that was, can you hear me now again? Great. So that was my colleague, Jackie Romero, and she was walking through the university campus with another colleague, Joel Carpenter, who's in the engineering department. Jackie's an optical physicist doing quantum optics, building quantum gates and so on with photons. And so she's one of the researchers that we have in the School of Physics who do quantum science. And so there's a variety of other research programs we have. So we have people doing superconducting device physics, ultra cold atoms, quantum optics, and nanomechanical systems. And I'm a theoretical quantum physics person, so I do calculations along with the experimentalists in the group in the research groups. So the master's program offers a variety of courses. It takes 18 months to do if you do it at the conventional rate. Of course, you can take longer if you wish to do it part-time. And you can find out the sort of technical details by going to the Master of Quantum Technology webpage at University of Queensland. If you just type UQ MQ Tech, you'll get through to the program. It's the kind of material that you cover in the course. It's built on some core units. They're part A, and there's about 9 of those that's available, and then some optional units in part B, which you can choose from a variety of different topics. And the part A courses are really structured in part around the conventional quantum physics courses that people learn in undergraduate physics. And the idea is really to train people who've got technical degrees already, engineers or computer scientists or mathematicians who want to enter the quantum space, bring them up to speed with the technical background required to understand quantum technologies. And so you can see we have conventional courses like quantum physics, introduction to quantum mechanics, laser physics and quantum optics. And then there's a new course we're teaching called Quantum Technologies, which is where we bring all that material together, that basic undergraduate or fundamental undergraduate quantum physics learning, and we bring it together in a course that really focuses on quantum technologies per se. So quantum computing, quantum sensing, how to build quantum systems that are going to be interesting and useful for quantum industries. And in parallel with those core courses, there are 3 project A, B, and C, not terribly creatively named, but they're often 1 per semester, and each project operates within a different research group that you can have access to during the program at UQ. So they're semester-long research programs embedded within research groups doing research in quantum science. So they're research programs, not lab projects, where you'll be exposed to current quantum research practice. So that quantum technologies course, that specific sort of capstone course that we offer, happens in the latter half of each year. The second in Australia, the semesters run from January through December, and so the quantum technologies course is at the end of the program. That is the second half of each calendar year, and and its objective is to cover the principles of quantum technologies, which includes how to apply them in experiments and understand how to do things like high precision sensing, quantum information, quantum computing, and computation. So that's really the focus of the program, is to get the material required to understand all of that, those subjects which are the subject of quantum science and quantum industry. So there's another useful planner web page which is available for people wanting to do postgraduate work. So the master's program is a postgraduate course. The prerequisites for that are essentially that you've got a technical degree from some topic from engineering through to maths or computer science, or allied disciplines in that space. And essentially, if you understand, if you've done a course in calculus and a basic physics, first year physics course, then you'll have the prerequisites essentially to do the Masters of Quantum Technology. That is, it's a program that's designed to take people with technical backgrounds and give them the basics and bring them up to an advanced level in quantum mechanics and quantum technologies. And so this planner gives you a bit of a map as to how the program runs. As I said, it's offset from the calendar year. It starts mid-year. The intake is mid-year, and you start with basic quantum mechanics, second year quantum mechanics, and a couple of other courses, including the first research project, which you do in that semester. There's the middle semester of the program, you do 3 more courses and another project. And in the final semester, you do another 3 courses and the final project with that quantum technologies course happening during that semester. So the first cohort is currently studying that final semester of the 3-semester long program. So I don't have very much more to say. I'm going to show one more video of Jackie. It's from the same series that you can find on YouTube if you like. It's only 20 seconds, so let me just play that where she goes through why one might want to study a Master of Quantum Technology at UQ.
If you want to get into the quantum startups, quantum technology space right now, this is a good 18 months, 2 years that you'd be able to just walk into that company and have something to contribute.
Great. So I'll end there. I'm happy to take questions. And of course, I'm also happy to take questions offline if people have them. You can find my contact details at UQ. If you type UQ Tom Stace, you'll get through to me. There we are. And there's my email address. So feel free to get in touch with me if you've got any questions, if you watch this after the fact. So thanks very much.
Thank you, Tom. Much appreciated. Any questions from anybody before I start asking questions and taking over the microphone?
Yeah. Hey, Tom. Heather here.
Hello.
Hi, Heather.
Great presentation. So could you tell us a little about the different the research that is happening at your place related to quantum computing?
Sure. So let me jump to equus.org. So this is the first place I'll start. So the research centres in Australia are national spanning entities. So equus, which is the centre that I'm deputy director of, has nodes in, the central node is at UQ, and it goes right across the country. And so the kinds of things that we work on are, well, we have these 3 themes. So we have a theme on designer quantum materials, which really boils down to coming up with new superconducting or ultra cold atom systems, or even quantum optical systems that have advanced quantum properties. That is, they reject noise or implement quantum error correction at their heart. let's see what we get if we go through there. That's just text. Okay, so the other, we have another theme which is around quantum-enabled diagnostics and imaging. So people looking at how you can do imaging better, new MRI systems and so on, measuring biological properties of systems with nanomechanical oscillators and that kind of thing. And then we have another third theme, which is in quantum engines and instruments, and that covers things like new types of detectors for subatomic particles. So one of the proposed models for dark matter suggests a thing called axions, a massive particle called axions. And so we have a group in Perth whose core interest is in trying to develop new microwave superconducting devices for axion detection. So we have a variety of groups across the country. If I click on laboratories, you can see the sorts of things we do. We've got people working on Bose-Einstein condensates. We've got people working on nanodiamond vacancies. We have people who work on timing and clocks. We have people at UQ again working on photonics. That's Jackie Romero's group, who you saw in those videos. And you can, if you scroll through, you can see there's a variety of different research directions that are going on within that centre. Now that centre is not located solely at the University of Queensland, it's across a variety of other places. And so if I look up UQ Quantum Science, you'll see the kinds of things that we do at UQ specifically. And here's the various research groups. So there's a quantum technology lab, which is Jackie Romero's lab. There's another quantum science lab run by Professor Andrew White, who's in fact the first person to build a optical C0 gate in the late 90s, early 2000s. And we have a variety of other research groups that you can see there. So, and of course, there's always a variety of quantum theorists at any institution that support the experiments that go on, and that's my particular research. So I myself work on superconducting qubit systems, and I also work on quantum error correction, as well as quantum sensing in a variety of platforms, including atomic systems and optical systems.
Okay, sounds great. Yeah. So the students that come to your university, so on graduating, do they tend to stick around for research, to continue in a field of research, pursue a PhD, or do students prefer going to industries for jobs?
So historically, I would say our research. So University of Queensland is a research-intensive university, and so the top undergraduate students tend to go on to do PhDs either at UQ or elsewhere, and likewise we have a strong intake of PhD students from both from around Australia and from abroad. So we have a strong research emphasis at the university. In terms of the master's program itself, we've had only the first cohort is finishing the program now. And it's a small initial cohort. As programs begin, they start off small. So we've only got a graduations for that. We expect to happen early next year. And so where students have ended up is yet to be answered. We haven't had any students yet complete the program. That'll be in the next couple of months. They'll finish up.
Okay. Yeah. Thanks a lot.
I'll click through to this quantum science projects, which lists a variety of different research projects that you can undertake with people at UQ. It's listed by honours, by different levels of study. So honours is like the final year undergraduate program. There's master's programs. There's PhD programs, and then there's summer and winter programs. So for the master's research programs, they will look like semester-long subjects, and you can see For instance, here I show up here. I offer some projects around quantum error correction, different designs for superconducting quantum devices, and a variety of my colleagues offer different subjects. So if you want to find out what are the sorts of research problems and areas that people are working on, you can click through to those. Any of those honours or masters would be suitable projects for people to work on. So let me point out a few different things that people work on. So Fabio Costa does foundations of quantum mechanics. So if you're interested in the foundational questions of how does quantum mechanics take the form that it does, then we have people working on that. Ian McCulloch is a numerically intensive researcher who works on these things called tensor networks or matrix product states, which are advanced methods for calculating properties of condensed matter systems, including quantum condensed matter systems. We have Matt Davis, who is a theorist as well, who works on superfluid systems, so largely cold atoms, but also superconducting devices. They've had some very important work recently on quantum turbulence. So if you go to the journal Science, you can find a series of papers last year on studying turbulence, vortices, and so on in superfluid helium. And you can see as you click through, you'll find Tim Ralph is another well-known quantum scientist who does relativistic quantum information. So you can click through at the quantum science projects that are available at UQ, and that gives you a flavour of the sorts of research that people are doing right now and that you'd be able to participate in through the 3 semester-long research projects.
Yeah, Tom, you sort of anticipated one of the questions I was going to ask, so thanks. So you're located in Canberra, am I saying that right?
We're in Brisbane, so
in Brisbane.
Yeah,
okay.
There's 7 states in the country, and Canberra is the capital of the nation. So we have 6 large cities. 6 major cities around the country. We're in Brisbane, which if you can picture Australia on a map, sort of shaped a bit like 2 brackets, and we're over on the lump of the east coast, where it's the easternmost major city in the nation.
Forgive me, I knew it was Brisbane, but Canberra came out. Nice area there, actually. So is the campus, would you call it a city campus, uncity campus, a rural campus? How would you? What's the geographic?
No, it's very city based. So there's Australia for those who haven't looked at it recently, and Brisbane is way over here on the right hand side. So if I zoom in on Brisbane, let me go to where Brisbane is. So it's geographically it's located between 2 really beautiful coastal areas, the Gold Coast and the Sunshine Coast, and there's some fabulous islands off the coastline. If I zoom in, here's Brisbane itself. This is the roughly in the middle of the screen there is the CBD. So that's the Central Business District, and it's a city of about 1.5 million people. So it's a decent sized city, certainly by Australian standards. And then now you can start to see where the University of Queensland is. It's this spur of the river down here. So it's a university that's nestled in a loop of the river. There's a beautiful ferry system that takes you from the campus into the city and beyond. And the university itself is a nice sandstone affair. You saw a little bit of that in the video that I showed of Jackie walking around. So if I scroll back, you can see some of the scenery around the campus. It's sandstone and so on. They're just below my office, actually, just right there. If they looked up, they'd see me, see the windows looking out from my office. So it's a very, very nice spot to be physically. The city of Brisbane is a place that I like very much, and I think that's not an uncommon view as well.
I had the pleasure of visiting Brisbane I don't know, maybe a decade ago. I was out there, went to one of the islands out there, I forget the name of it, that research island.
Is Heron Island?
Heron Island, yeah.
Mm-hmm.
Yeah, that was a wonderful experience. There was actually a conference out there, so we spent like a whole week there. Yeah, you had to take this ferry on very choppy waters to get there, though.
That's right. Like it's famously choppy.
Yeah, like the whole boat's practically passing out.
But you can see the scale of Australia, and as I was talking about EQUIS, the Centre for Engineered Quantum Systems, it has researchers in Brisbane, in Sydney, in Canberra, which you mentioned before, and way over here in Perth. So we have research nodes, that is the Centre of Excellence that I'm in has research nodes right across the country. And actually that's one of the strengths of the research program across Australia, is that it's reasonably joined up and people work closely together. And certainly within the master's program, if one finds an interest in some of the work that's going on around the country, it's possible to integrate that as well.
I noticed, in Australia, there's increasingly more and more and organized activity going on in quantum. It may not be readily apparent to all of us all the time, but Australia is definitely taking note of this technology and certainly putting money where their mouth is, et cetera. So,
yeah, well, as I said at the start, I think we can boast the first theoretical proposal for a quantum gate, and that was the one I showed at the start in 1989, and we have the first optical quantum gate that was done in around 2000 by Andrew White. So yeah, Australia's been working at this game for a long time now, and so it's something that we're proud of, and the rest of the world absolutely is catching up and going beyond in many ways, and yet we think we can contribute usefully to the research.
Absolutely. I mean, I think an individual there can make an impact, in that area there. Quantum in general, but in Australia in particular. Any other questions? I've got one more as a reserve. Anybody else? Yes, Australia is a wonderful place to visit. I would imagine going to school there would be just as fun. So of the outsiders, the non-Australian nationals that go through, the quantum program, the master's is obviously new, so you don't have a lot of data points on that. But in general, do the non-Australian nationals tend to stay around Australia, or do they kind of educate and go broadly? I mean,
so I'd say so in terms of the master's program, we have no data on that because the first cohort is yet to complete. In general, for people who do physics degrees, as people listening may be aware, there are jobs for physicists all over the place. Unlike, say, engineering or computer science, those jobs are not always well defined up front. So physics is not really a vocational degree. It's a basic science degree, and so where people end up is in all sorts of sectors, and of course all around the world. So Australian physics graduates in particular have gone, and specifically those from UQ have gone all over the place, and in fact a variety of quantum computing and quantum technology efforts, commercial efforts around the world are being run by Australians. So Jay Gambetta is one of the leads in IBM in New York, and he did his undergrad and PhD in Brisbane at another university, Griffith University. Jeremy O'Brien, who people may have heard of, who's running a company in Silicon Valley, went through University of Queensland, and essentially in a lot of different quantum technology startups, you'll find Australians working, and so in this area there are a lot of us around the world.
Yeah, definitely seen Australia in backgrounds of many people. You mentioned a few of them there. So Yeah, it's a good.
So we certainly have
good,
alumni from our quantum
Yeah.
science program
Yep.
distributed around the country and around the world.
Terrific. Okay, Tom, thank you very much. I appreciate you staying up late.
You're welcome.
You know, in Queensland time, and taking care of this business here. And I hope we'll get some students enrolled in your program over time.
Great. Thanks very much.
All right. Thank you, Tom. See you around.
Bye.